Imagine a world where the ground beneath Los Angeles isn't paved with concrete, but treacherous, bubbling pools of asphalt. It is the late Pleistocene, roughly 15,000 years ago. The air is cooler, the grass is taller, and the silence of the basin is broken only by the distant bellows of mammoths. Beneath the surface of the earth, a biological archive is being written. Today, we know these as the Brea Tar Pits, but to the creatures of the Ice Age, they were a deadly trap. Our story begins with the discovery of a skull, thousands of them, actually. In the early 20th century, as paleontologists began excavating the dark, sticky pits, they found an overwhelming number of canine remains. These weren't the bones of the coyotes or the gray wolves we see today. They were heavier, denser, and far more numerous. In fact, over 4,000 individual specimens have been pulled from the tar, making it the most well-represented carnivore in the fossil record. Scientists originally named this beast Canis dirus, the fearsome dog. For over a century, the world viewed the dire wolf through the lens of modern biology, assuming it was simply a larger, stockier cousin of the gray wolf. We pictured it as a wolf on steroids, a cinematic monster that patrolled the plains of North America alongside giant sloths and saber-toothed cats. It was a creature of myth and legend, cemented in our minds as the ultimate pack hunter of the Americas. But these fossils tell a more complex story than just size. When you hold a dire wolf's skull next to a gray wolf, the differences are striking. The sagittal crest, the ridge at the top of the skull where jaw muscles attach, is massive. This was a predator built for a different kind of violence. It was a titan of its era, a specialized heavy hitter that thrived in a world of giants. In this first chapter, we step back into that prehistoric landscape. We look at the sheer scale of the dire wolf and why its presence was so dominant that it outnumbered almost every other predator in the fossil record. We are beginning a journey to uncover the truth of a predator that has been misunderstood for 100 years. This is the titan of the Pleistocene, and as we are about to learn, it was far more unique than we ever dared to imagine. For over 100 years, the scientific community lived under a massive misconception. Because the dire wolf looked like a wolf, moved like a wolf, and hunted like a wolf, we put it in the same genus as the gray wolf, Canis. We assumed they were close cousins, perhaps even a direct ancestor or a sister species that simply grew larger to handle larger prey. But in 2021, a groundbreaking study published in the journal Nature shattered that assumption forever. Scientists managed to do the impossible. They extracted ancient DNA from dire wolf remains that had been preserved for tens of thousands of years. They compared this genetic code to gray wolves, coyotes, jackals, and even African golden wolves. The results weren't just surprising, they were revelatory. The data revealed that the dire wolf and the gray wolf hadn't shared a common ancestor for nearly 5.7 million years. To put that in perspective, that is roughly the same amount of time that separates humans from chimpanzees. While the gray wolf evolved in Eurasia and only crossed into North America relatively recently, the dire wolf was a true all-American predator. It had evolved in isolation in the Americas, developing a body plan that mimicked the wolf because that shape was the most efficient way to survive in their shared environment. This is what biologists call convergent evolution, two unrelated species evolving similar traits because they solved the same problems. The direwolf was so genetically distinct that it was officially moved out of the Canis genus. It was given a new scientific name, Aenocyon dirus, which translates to terrible wolf. It wasn't a wolf at all. It was the last surviving member of a ghost lineage that had been roaming the Americas alone for millions of years. This discovery changes everything about how we view this animal. When a gray wolf looked at a dire wolf across a Pleistocene valley, it wasn't looking at a cousin, it was looking at a total stranger, a biological outsider that had mastered the continent long before the first true wolves arrived. In this chapter, we explore this genetic revolution and what it means to be a wolf that shares no blood with the pack. If the gray wolf is a high-speed pursuit vehicle, the dire wolf was a heavy-duty tank. To understand how Aenocyon dirus dominated the landscape for millions of years, we have to look past the fur and into the architecture of its skeleton. This wasn't a predator built for long-distance marathons. It was built for the struggle. It was a specialist in the art of the takedown. When paleontologists examine the fossilized limbs of a dire wolf, they find bones that are significantly thicker and shorter than those of a modern wolf. This structural difference tells us everything about their lifestyle. While a gray wolf uses its long, slender legs to exhaust prey over miles of territory, the dire wolf was designed for explosive power and stability. It was a wrestler. Once it closed the gap, it used its massive frame to anchor itself to struggling megafauna, refusing to be shaken off by a thrashing bison or a terrified ancient horse. But the true secret of the dire wolf lay in its skull. The biting force of Aenocyon dirus was roughly 129% that of a modern gray wolf. If you look at the teeth, you'll see they weren't just sharp for slicing meat, they were reinforced for crushing bone. The carnassial teeth, the large teeth in the back of the jaw, were massive, designed to shear through thick hide and crack open the femurs of giant herbivores to reach the nutrient-rich marrow inside. This suggests a dual role. They were apex hunters, but they were also the ultimate scavengers, capable of finishing off carcasses that other predators had to leave behind. Their diet was a who's who of the Ice Age. Chemical analysis of their tooth enamel reveals a preference for ancient horses and bison, but they weren't picky. In the coastal regions, they likely scavenged on beached whales. They were the cleanup crew of the Pleistocene. However, this hyper-specialization was a double-edged sword. They were so perfectly tuned to hunting large, slow-moving prey that they became dependent on them. In this chapter, we dissect the mechanics of a kill. We look at how a pack of dire wolves would coordinate to bring down a western camel or a juvenile mammoth. We explore the cost of being a heavyweight, a body that requires massive amounts of calories just to keep moving. The dire wolf was a masterpiece of biological engineering, a predator refined by millions of years of evolution to be the most efficient killing machine the Americas had ever seen. But as the world began to change, that very perfection would become its greatest liability. The Pleistocene landscape was not a lonely place for a predator. It was a crowded, violent theater of competition. To survive, the dire wolf had to hold its ground against two of the most formidable rivals in evolutionary history, the saber-toothed cat, Smilodon fatalis, and the newly arrived immigrant from Eurasia, the gray wolf. This was a battle of styles, strategies, and survival of the fittest in a world that was rapidly running out of room. For a long time, we pictured the dire wolf and the saber-toothed cat as bitter enemies, constantly clashing on carcasses. The fossil record at the Brea Tar Pits confirms this overlap. Both species are found in massive numbers, often in the same traps. However, recent studies of their bones suggest they actually managed to split the neighborhood. While the saber-toothed cat was an ambush predator, using its immense upper body strength to pin prey and its blade-like teeth to deliver a precision throat cut, the dire wolf was a social endurance hunter. They weren't necessarily fighting for the same kill every day. They were filling different roles in the ecosystem. The Smilodon took the heavy brush, while the dire wolf ruled the open plains. The real threat, however, came from a much smaller, scrawnier relative, the gray wolf. While the dire wolf had spent millions of years evolving in the Americas, the gray wolf crossed the Bering Land Bridge much later. On paper, the dire wolf should have crushed the interloper. It was bigger, stronger, and had a bite that could snap a gray wolf's leg like a dry twig. But the gray wolf brought a different toolkit. It was faster, it required fewer calories to maintain its smaller body, and it was a generalist. While the dire wolf was locked into a heavyweight lifestyle, the gray wolf was flexible, willing to hunt smaller, swifter prey like deer or rabbits that the bulky dire wolf simply couldn't catch. In this chapter, we look at the social dynamics of these packs. We explore the evidence of healed injuries found in dire wolf fossils, broken hips, and fractured jaws that had time to knit back together. This proves they were deeply social animals. A lone dire wolf with a broken leg would starve, but a packmate would be fed and protected by the group. This social bond was their greatest strength. Yet as the climate began to shift and the megafauna began to dwindle, the competition grew desperate. We examine the tension of a world where three apex predators were hunting the same shrinking pool of prey, and how the titan began to lose its crown. By 13,000 years ago, the golden age of the American megafauna was screaming toward a halt. The world was warming. The massive glaciers that had defined the landscape for millennia were retreating, and the mammoth steppe, the endless salad bowl of high-protein grasses, was being replaced by forests and bogs. For the dire wolf, this wasn't just a change in weather, it was a total collapse of its supply chain. As we reach the final chapter of our story, we have to face a haunting reality. The very traits that made Aenocyon Dirus a titan were the same traits that ensured its doom. The dire wolf was a specialist. It had spent millions of years perfecting the art of taking down the biggest, slowest, and most dangerous animals on the continent. But as the giant bison, the ancient horses, and the mammoths began to blink out of existence due to a combination of climate shift and the arrival of a new two-legged super predator, humans, the dire wolf found itself in a world it no longer understood. When your body is built to wrestle a ton of muscle to the ground, a white-tailed deer is a ghost you can never catch. While the smaller, leaner gray wolves were able to pivot, hunting the smaller and faster prey that survived the Great Extinction, the dire wolf was trapped by its own bulk. It required a massive caloric intake just to survive the day. As the big meals disappeared, the dire wolf began to starve. There is a tragic silence in the fossil record. We see their numbers plummet. We see their teeth becoming more worn, suggesting they were forced to crunch every last bit of bone from increasingly rare carcasses. Unlike the gray wolf, which could interbreed with coyotes or other arriving canine lineages to diversify its gene pool, the dire wolf was genetically isolated. It had no close relatives left to bridge the gap. It was a branch of the tree of life that had grown long and heavy, only to find itself with nothing left to hold on to. The last of the terrible wolves likely vanished around 10,000 years ago. They didn't go out in a single climactic battle. They simply faded into the shadows of the new forests, unable to keep pace with a faster, hungrier world. Today, they exist only as bones in the tar and as ghosts in our DNA studies. They remind us that even the most powerful king can be toppled when the world beneath its feet changes. The dire wolf was the true American original, a masterpiece of the Ice Age that stayed behind when the ice finally melted.